Hi, good morning. And today we are going to be talking about equations of lines. Now, there are a couple of different ways of writing these equations of lines. The first one that I want to mention is called standard form. And it is marked right over here. This right here is the standard form where you have some coefficient times x plus some coefficient times y is equal to some constant c. This is one of the ways in which you can find an equation of a line. You may need to rearrange it in order to get it into a format that we will usually use in order to be able to graph the line, okay? However, the one that is really, really important to us is actually slope-intercept form. Which is right here. Y equals mx plus b. And that's the one that students usually remember. Something to keep in mind is that slope is represented here as m. And b typically represents the y-intercept. If I were to write it as an ordered pair, it would usually be your x coordinate being 0 and then your y coordinate being your b, okay? So given that information, I'm going to write an equation of a line. So I'm going to be given a y-intercept and I'm going to be given a slope, and I'm going to come up with the equation of the line. So it says, we're not going to graph it, we're just going to write the equation of the line. Okay, so we're going to practice doing it. So y equals, I'm going to have a spot for the m, x plus, and then a spot for the b. So my m, which is my slope, is going to be negative 2/3, and that's what I'm going to put in, negative 2/3. And then my spot for my b, I'm going to plug in what they tell us our y-intercept is, which is 2. Okay, now I didn't actually draw a graph, or yeah, maybe we won't graph it. How about that? I'm just gonna bring this right there. Here we go. Okay. Maybe not. I changed my mind because this is being a little finicky. Let's see if I can move it now. There we go. Okay. So when I graph anything having to do with the slope, I say that B stands for beginning. It's where you begin your graph. Okay, and so again, I am going to start where your y is 2. And keep in mind, we need to make sure that we are on our y-axis for that. So y is 2. And then we know that the slope, okay, tells us how much we go up and to the right. So if I have a negative, that means to say either the numerator or the denominator, not both, is going to change directions. So we are having negative 2/3. So I'm going to go down and then to the right. Or I can go up and to the left. Both of which are going to work just as well. So I'm going to go down 2 and to the right 3. 1, 2, 3. Down 2 to the right 3, down 2 units to the right 3 units, or I could go up 2 and to the left 3, up 2 and to the left 3, and I can keep going. Then all I would need to do is really connect the dots. And I just graphed an equation of a line. Isn't that exciting? Okay, so that's one example. Now, another example is if I'm given a slope and a point. I'm not given the y-intercept, I'm just given a point. However, this does not change because my point is going to be xy, and I have what my m is. So instead of plugging in for b, I'm going to plug in for xy, find what b is, and then go ahead and plug it into my slope-intercept form. So this is how it would work. I'm going to plug in the -3 in for y, so I have -3 is equal to my slope, which is 4, times my x value, which is -1, plus b. And we are going to solve for b. So I'm gonna multiply what I need to multiply, which is 4 times -1, which is -4. Then I'm going to add 4 to both sides. I'm going to bring it up here. So I have 1 is equal to b, which means my slope-intercept form is going to be y is equal to my slope times x plus my b value, which is 1. That's my equation of the line. If I wanted to graph this, I'm going to start at the beginning, b, which is 1. Okay, and then I'm going to start moving around. Now I have a +4, but since I don't have a fraction, I'm going to make it into a fraction, which is always going to be, a whole number is always going to be over 1. So I'm going to rise up, I'm going to go up 4 units, 1, 2, 3, 4, over 1 unit. Up 4 over 1. Now I can also go down 4 into the left 1. Down 4 into the left 1. And again, then all you need to do is connect the points. Now, here's the last example. I'm going to ask you guys to find now both the slope and we need to find our y-intercept before we can even go ahead and write down the slope-intercept form. So what I'm going to do is I'm going to first find my m by stacking and subtracting, because that's my method, my preferred method. Okay, so I have 6 minus 4, which is -10. -2 minus a -3, which is 1. I'm sorry. Yeah, there we go. So I'm going to go over. So I have -10 over 1. And that's my slope. Now I'm going to find my b. So I am going to use one of my 2 points. Doesn't matter which one, I'm going to pick that one. And that's going to be my x value, and that's my y. So my y is 6, and that's equal to my slope, which is -10, times my x value, which is -2, plus b. So now I'm going to do my multiplication, so it becomes a +20 plus b. And then I'm going to subtract 20 from both sides of the equal sign. That cancels, and it becomes -14 is equal to b. So my equation is going to be y is equal to my slope, which is -10, x, plus my b, which is -14. Now I'm not actually going to graph it, but I did want to show you how to find the equation of a line using 2 points. So just to recap, you could have a few different things going on. Thing number 1, you could be given the slope and the y-intercept. That is the best case scenario. Situation number 2 is where they can give you a point and the slope. So you would have to find the b first, and then you could come up with your slope-intercept form. And then worst case scenario is where you have to find both your slope and your y-intercept because you're only given 2 points. Okay, so those are the 3 potential situations. I'm going to skip over the u-try. You can definitely try that on your own if you would like. If you want to screenshot it and try it on your own, You absolutely can. We will do some more practice after the video. But the last thing I kind of wanted to talk about here are some very specific examples of lines. Okay, so if I were to say graph the line y is equal to 5 and find its slope. So y is equal to 5 really is saying when my y value is 5. So where's my y value 5? Well, my y value 5 is right there, but it could also be here. It could also be here. It could also be here. It could be pretty much anywhere along this horizontal line. Okay? So having said that, if we look back to our slope video, this is a horizontal line, which means the slope of any horizontal line is 0. Okay, so we know now that y is equal to 5 is going to give us a horizontal line. In fact, any y equals a number is going to give us a horizontal line. Now let's take a look at the next one. Graph the line x equals -3. Well, when is x equal -3? -3 is right here. Okay, and where else will x equal -3? Well, it's going to equal it down here, and up here, and there. Pretty much anywhere along this vertical line. Let's pretend that that's actually a really nice vertical line. I realize that it is not. So basically, x equals -3 is going to be a vertical line. And essentially, anything that has x equals some number is going to give me a vertical line. Okay? And we know that the slope of any vertical line is undefined. Okay? So those are some big things to remember. Oops, sorry about that. Went too far. So, to remember, horizontal line, we're talking about a coordinate plane and we're talking about the line being horizontal. Vertical, we're talking about a coordinate plane and we're talking about that line being vertical. We know that the equation for a horizontal line is always going to be y is equal to some number. And we know that the equation for a vertical line is always going to be x equals to some number. And we know that the slope of a horizontal line is always going to be 0. And we know that the slope of a vertical line is always going to be undefined. So that is just a nice little recap of what it is that we are looking for with equations of lines. So now we're going to move on to parallel and perpendicular lines, which is going to be the next video.